A sliding wire of length 0.25 meter and having a resistance of 0.5 ohms moves along conducting guiding rails A, B, and CD with a uniform speed of 4 meters per second. A magnetic field of 0.5 Tesla exists normal to the plane of ABCD, directed into the page. The guides are short-circuited with a resistance of 4 ohms and 2 ohms as shown. The current through the sliding wire is. Okay. First, let's try to find what is the EMF induced within the sliding wire. EMF induced is BLV. The value of B is 0.5. Length is 0.25. V is 4. That is 0.5 volts is the EMF induced. Right. What is the net resistance? This 4 ohms and 2 ohms are in parallel. So equivalent will be 4 into 2 by 4 plus 2, which is 8 by 6 or 4 by 3 ohms, which is in series with 0.5 ohms. So our total is 4 by 3 plus 1 by 2, which is 8 plus 3 by 6, which is 11 by 6 ohms. And this is the EMF. So the current passing through MN, the sliding rail is I is E by R, which is 0.5 by 11 by 6, which is 1 by 2 into 6 by 11 or 3 by 11 amperes. What is the value of 3 by 11? 3 by 11 would come to 0.27 amperes. That would be option.